Hello. Yes, once again, welcome to yet another containerization series featuring our esteemed guest speaker, Maria. Maria took us initially through the Docker session, and it was really insightful because we managed to walk through introduction to containers, looked at container engines such as Docker and Podman. We also we had the practical hands-on as well as best practices. Yeah, so a recording for this was recently uploaded on our YouTube channel. Yeah, but for this session, we're going to focus more on container orchestration and Kubernetes as well as best practices. Once again, welcome, Maria. I think over to you.
Thank you very much, Stephen. I'm really glad to finally come and share the second part of our previous session regarding containerization. And I think I'll share my screen. Okay, for those who were not here for the previous session, I'll give a small recap of what we went through. We introduced Kubernetes last time and why we need Kubernetes, why we don't need Kubernetes. And we also talked about the components and when not to use Kubernetes. So I'll do a quick walkthrough of this, then I'll dive right into the demo for the sake of those who are not around. But we discussed that we need Kubernetes because of its benefits that Docker Compose cannot provide, or it provides on a smaller scale. So with Kubernetes, it talks about scaling. It helps you with different ways of scaling. You could do horizontal pod auto-scaling, vertical pod auto-scaling, and cluster auto-scaling. What is scaling? So in case you have like large traffic visiting your website, visiting your application at the same time, sometimes the resources of your cluster may not be sufficient to manage the large volumes of traffic. So with the presence of scaling, Kubernetes will know that your system is under load, and it will either increase the number of pods that are running in the background, or it will increase the size of your nodes. We shall talk about the nodes and pods later in this session. Then it also helps with self-healing in a way that in case your application is down or one of your pods in the application is down, the kubelet will inform the control panel, will inform the controller manager in the control panel that this is down, then it will spin up a new pod. So you will not even notice downtime. Then it also supports with load balancing, knowing where to transfer traffic, which service to transfer traffic to. Then it helps with rolling updates. And those are deployments where you do not have to, your app does not have to go down for the deployment to be successful. Then disaster recovery and high availability. Clusters tend to run in different availability zones. So in case one zone is down, your cluster is able to spin up. I mean, it's able to keep running in another. Then we also did a walkthrough with the architecture. We say there's always the control plane, and then there's the node. You can have multiple worker nodes. You can have multiple master nodes. Those are the control planes, depending on your architecture. For example, if you're running in production to have a highly available cluster, you could have different master nodes. Or if you're just testing stuff out on dev, you could have a single node that can run both the control plane and the worker nodes. So we also looked at the components in the control plane and what each does. So from the extreme right, we have the etcd. The etcd is like the database of your cluster. It stores state about your cluster, and this communicates with the API server, and the API server is able to serve the requests based on the state in the etcd. Then we have the controller manager. This manages all the controllers that you've had. We've talked about deployment, we've talked of a pod and other controllers. So the controller manager manages this, and it's able to spin up new pods in case one is down. And then we have the scheduler. The scheduler is in charge of scheduling pods to different nodes. Some nodes usually don't have capacity, and the scheduler will determine where to place your node based on where to place your pod based on how you've defined your pod, the rules that you've set, the anti-affinity rules, etc. So we have the worker nodes on the left, and each worker node has to have a kubelet, because a kubelet is like a messenger that transmits messages between the worker node and the master. Then we also have the kube proxy. This manages networking in a way that sometimes pods need to talk to each other. For example, you have front-end pods, back-end pods, they need to communicate. This kind of networking is managed by the kube proxy. Then this slide just explains what we've talked about, what each service does. So we'll quickly skip that. Then we mentioned that there are different ways of running your Kubernetes cluster depending on your environment. Sometimes if it's the production environment, it's always advisable to have a resilient setup that in case one master is down, the others can keep running. So in the left picture, we have the master, 2 masters, and 4 nodes, 4 workers. These workers is where we have our pod deployments, our applications, and the master is the control plane, is the command center. So this is where we have everything that manages the cluster. Then in the test environment, you can have a single node, and the single node can run master and worker processes. The good example is Minikube. Minikube can run on your laptop, and on Minikube, you can be able to start a process. You can run the Minikube dashboard to see how the setup looks like. Another way of building a cluster could be, well, this explains Minikube in depth, and the instructions there. So with Minikube, you can simply download Minikube on your laptop, then you run Minikube start. So Minikube, the download for Minikube will also include kubectl, so you no longer need to install it separately. So these commands, Minikube start, Minikube status, you can see the state, whether it's running or not. Minikube dashboard, you can see the dashboard, or Minikube delete to delete the single node cluster. Then another method is kubeadm. Sometimes if you want to set up your cluster from scratch without having some other service managing your control plane, you could do kubeadm. And kubeadm, you get different sets of nodes, and kubeadm join will join those nodes to the control plane. What creates the control plane is the kubeadm init. Then kubeadm join will make these nodes join the control plane to form a kube cluster. Then another way is kind. Kubernetes in Docker. This is what we shall be running today for our demo. So kind is also used for test environments. And it runs a local Kubernetes cluster. You can do a single node cluster that has both the master and the worker processes, or you can run multi-node clusters with kind. So sometimes you can install kind via brew if you're running Mac, or other methods for other operating systems. Then you run the command kind create cluster, then you're good to go. There's also another way. The Docker desktop now provides ability for you to run a Kubernetes cluster via kind. So it's now supported, but it's not yet stable, but it's supported. So we shall try that today to set up a small Kubernetes cluster to get started. Another way of setting up a cluster could be managed services. So sometimes you don't want to have the stress of running the control plane, of managing the control plane on your own. Sometimes stuff get outdated and you need to update stuff. So using the managed Kubernetes services, like on different cloud providers, you're able to get running very fast without having to have the nitty-gritties of the kubeadm. Then we have kubespray. Kubespray also runs in production. You're able to set up a kube cluster with Ansible, a config management tool. And yeah, it's also good to go. You're able to manage it on your own without having to use managed services. So it depends on your preferences as a team to determine what method you can use to run the cluster. So I'll go through the demo today. So as I mentioned that you need to have Docker installed for you to run kind Kubernetes in Docker. And once you have this Docker desktop, this is the easiest way. You could go to settings here. Then on the settings tab at the left, there are a couple of options. So we have Kubernetes as one of them. So when you select Kubernetes here, you toggle this button to enable Kubernetes. And once you enable Kubernetes, you can choose a cluster provisioning method. Previously, we used to have kubeadm as the only option, but now we have kind. And with kind, you can select the kube version that you want to run. You can select the number of nodes that you want to run, whereby this will create for you a cluster. So right now we have a cluster created, and after selecting these options, you click apply, then it will create for you a cluster. And how do you get to know that the cluster has been created? So we have what we call a kube config. Yeah. So for every Kubernetes cluster in your system, there has to be a config file in the .kube folder. So this config file will show the different contexts that have been created. So currently, the Docker desktop has created this config. So how do you view this? To determine what you're running, I would do a kubectl config view, and this will show the current context that I'm running. So the current context is Docker desktop. Other setups on this laptop include Minikube. So if you want to change the context to Minikube, you could do kubectl get context. Oh, kubectl config get context. And it will show that we have Docker desktop as the current context, but then we also have Minikube. So how do we move to Minikube? So it's kubectl config use context Minikube. So once you get contexts again, it will show that the current context is Minikube. So the reason for this context thing is to help you not deploy your resources in a wrong cluster. So that's why you always have to check the context to know where you're working from, so you don't deploy your resources in different environments. So for now, we shall go back to the Docker desktop. Config set context Docker desktop. kubectl config use context Docker desktop. So to see the config, kubectl config view. So that's it. And now if you run kubectl, for example, get nodes, you can see that it has created 3 nodes. The 3 nodes that you defined here. And we have one of them is the control plane, and the other 2 are the workers. One of them is the master node, the control plane, and the other 2 are workers, and our resources will run on the workers. So after that, there are also some commands you can use to manipulate these nodes. You can describe a node. Describe node. And kubectl describe node will give you information about the worker node. The labels help you identify this node, and they help the kubelet know some information about this node. So you can use the labels as identifiers, and also the annotations are also a set of key value pairs that give more information about this node. Then we also have the node conditions. They tell you the status of this node. If it has memory pressure, it will show a message here. It has disk pressure, it will show a message here. If the node is not ready, the status will be ready, false. And that means this node will not be schedulable. You cannot schedule anything on this node. Yeah. Then it also has addresses, the IP of this node. We shall see that in case you want to reach your app via the node port, you can use this IP. Then it also has a section of the resources that are running on this node, the pods, and what memory and CPU they are consuming, when they were deployed. Yeah. And then it also has limits. So sometimes you define limits for your pods, that my pod should not exceed this amount of CPU. So all this information can be seen by describing a node. Then there are also other commands that you could use apart from describing a node. You can code on a node in case you don't want it to be scheduled. So we could code on that. So scheduling on this node is disabled. So even if you deploy whatever pod, it will not be scheduled on this node. The scheduler knows where to place it. You can uncode on a node. Sometimes people code on nodes because of health conditions, like in case the node has issues, networking issues, you could code on that. Then you can uncode on it in case everything is good to go. So it's back to the ready state. You can do different things with the node. If you go through documentation, you can see, you can label, you can see whatever you could do with the nodes. So another thing I want to talk about now that we're done with nodes is the namespace. So the namespace in Kubernetes helps you to separate logic. For example, you could be running your front-end application in a different namespace, for example, front-end, your back-end application in another namespace. It's like a logical separation of concerns, and it helps to bring some organization within the cluster. So how do you see namespaces? kubectl get namespace. So already there is a default namespace that's created whenever a cluster is created. So this default namespace stores all applications for which you have not defined a namespace for them. They'll definitely come to the default namespace. So how do you know you have something in the default namespace? kubectl get all -n default, or you don't need to define the namespace. You can do kubectl get all. That will still bring everything in the default namespace. Then there are other namespaces that are created as the cluster is being created: the kube node list, the kube public, and the kube system. Kube system is where you find most resources on the control plane. They are stored in the kube system namespace. Kube system get all -n, kubectl get all -n kube system. So you'll find so many resources that you could not find in the default. We have core DNS. This one manages translating these IPs that you see on nodes into readable names, core DNS. Then we have etcd. We said etcd is the store. Then KINnet, this is networking with Kind. Then Kube API server, this is the API server that responds to our requests. We said we could talk to the API server via the dashboard UI. We could talk to it via kubectl, or we could talk to it via curl, HTTP curl requests. Then the controller manager is what manages the controllers, the deployments, the stateful sets, the daemon sets. Then the kube proxy is in charge of interpod communication and any other communication within the cluster. Then the kube scheduler is what schedules pods on nodes. In case a node is unschedulable, the kube scheduler will skip it and look for a node on which it can place a pod. Then In the kube system, we have what we call a service. We shall see this in detail. So it lists for you all resources in this namespace. It has pod resources. It has a service. It has a daemon set. We shall look at these objects. It has a deployment and a replica set. So what else can you do with a namespace? You can describe a namespace. So let's describe a namespace kube system. So the namespace description gives you more information about the namespace, the labels, the status. You can delete a namespace, kubectl delete namespace, or you can create more namespaces and create your applications there. So back to our code. This is how a namespace looks like, namespace definition. So Kubernetes has two ways of describing resources. It has two ways of telling it what to do. The imperative method and the declarative method. So sometimes with the imperative is when you tell Kubernetes what to do and how to do it. Declarative, you just provide a file like this, then Kubernetes will do the rest. So with imperative, if I want to create a namespace, I'll do kubectl create namespace test. So it has created a namespace. So kubectl get namespace. The test namespace has been created 8 seconds back. But what if I want to use the declarative method? I will use this file. So I'll look for this folder that has a demo. Then I'll look for the folder containing the Kubernetes resources. So this folder, this work has been provided on GitHub in case you need access to it. It will be available. So we shall go to cd Kubernetes, then Kubernetes resources, and we want to create our namespace the declarative way. So you define a format, provide the name of the namespace. So in this case, let me call it demo app test because I've already seen a demo app namespace there. So I'll do kubectl create -f, that's the file path, namespace .yaml. So this has created a namespace. kubectl get namespace. You'll see that demo app test has been created. I can delete it, kubectl. I can delete it declaratively, kubectl delete -f, namespace.yaml. That will still delete it. So it's not there anymore, or I can delete it imperatively, kubectl delete namespace test. So that will also do the same. So you can use declarative methods where you define your object in a file and you just run kubectl create -f, kubectl apply -f, kubectl delete with the file path. If you use imperative ways, kubectl delete, then the definition here, if it's a namespace, if it's a pod, then the name. So that's it about the introduction to namespaces. Then the other resource that we'll talk about is the pod. So when we talked about containers, we mentioned that you can run containers in Kubernetes via a pod. The pod is the smallest unit in Kubernetes, not a container. So the containers have to run within a pod. So any containers that exist in the same pod have the same networking strategy, they have the same IP, they share the same volume. So the moment you run many containers in a single pod, they'll share whatever the pod has. Yeah. So how do you create a pod? You can create a pod imperatively or declaratively. Imperatively is when you run the commands kubectl run. For example, if I want to run a debug pod, busybox, then I pass the image busybox, for example, with its tag latest. So it creates a pod, kubectl get pods. It has created a pod in the default namespace. Yeah, it has created a pod in the default namespace, a debug pod. Then, how do you describe a pod? kubectl describe. So usually these commands are mainly the same. So it shows the container in busybox failed, but it shows the information about the pod. What's the information? It shows the namespace we're running in is default. It shows the service account of this container, like this is related to roles, and we shall look at the role-based access control. Then it shows the image that you're running. This image is usually pulled from the public Docker hub. And then it also shows the state of the pod, shows its ready status, that it's not ready because of an error. Then it also shows extra information about the pod. So how do I delete the pod? I delete the pod with still imperative way kubectl delete pod. That. Then another way to create a pod via declarative methods. Here you define the namespace, but also you can create it imperatively and define a namespace. kubectl run busybox-n demo app. Here you're providing a namespace for which it should run. So when I do kubectl get pod without defining the namespace, there is no resource, but kubectl get pod-n demo app, it will be here in the namespace. So that's how the namespace separates concerns. kubectl delete pod busybox. Without defining the namespace, it won't work, but -n demo app, it will delete it because it will be found only in the namespace. So declaratively, we go to other objects. Let's create a pod. Declaratively, kubectl create -f pod.yaml. So when you check the namespace demo app, this resource has been created 10 seconds ago. You can check the logs of this pod. Oh, one thing I forgot to mention about the pod. You can see the containers in this pod. So this is where the containers are. So there is busybox. But you could also add more containers here in the list as you have. So you could have more containers running in a pod. You could have sidecar containers. Sidecar containers also run alongside another container. For example, doing things like monitoring, getting metrics and logs. You also have init containers. You could also read into that. Init containers fulfill a specific job before a pod runs. For example, if a pod needs to run with specific files copied somewhere, the init container can do that for you. It starts, copies files from one place to the storage, then this other container will start. So it cannot start unless the init container has completed. So you can define init containers, or you can define sidecar containers, like they can run alongside these other containers. Then, what else? You can describe a pod, you can delete a pod, you can label a pod in case you want to uniquely identify it and reference it somewhere. You can label it. Yeah, so that's it about pods. Basically, there's so much more you can do, but basically that's it. Then the other unit is a deployment. So you can create a pod, you can delete, but then what if you want to have two of this same pod? What if you want to replicate it, like have these pods run multiple times? For example, there is an event that requires these pods to scale, to run so much of these pods, replicate them. What do? That's where the deployment comes in. The deployment is just an abstraction over the pod. You define kind deployment. You define the replicas here. We don't have this for the pod, but you define the replicas and you define your containers. So you could create a deployment imperatively, declaratively. So we could say kubectl kubectl create. Well, I don't know if this image exists in the Docker context in Kint. I will first say Docker images. Okay, the image exists. So kubectl create -f, then the path, which is deployment. I think I'm in the wrong folder. kubectl create -f deployment.yaml. So the deployment already exists. kubectl get deployment. So -a, in case you don't know the namespace, it will help you find it. So we have a deployment which already exists and we tried to create it, KDC. So let's remove it. kubectl delete deployment. It's in the demo app namespace. So it's deleted. We could now create it again. So it has been created. kubectl get deployment. It's here. It has been created 14 seconds ago. You can describe deployment. Describe deployment. It will give you more information about it. The containers that it's running, the status, yeah, and the events. This gives you more information about whether it's successful or not. So how do you know that the deployment has worked? You check for the pods. In this namespace, you'll see that it has created a pod, this one, KDC-random string, 60 seconds back. Now, it has created one pod, but we mentioned that the deployment helps you manage replicas, copies of different pods, of the same pod, by setting the replicas here. So after updating that, I could do kubectl apply -f deployment.yaml. So it has been patched. So kubectl get pods. It will show that we now have 4 copies of the same pod. So the deployment helps you manage replicas. If you want to scale back down, you could change the replicas to 1. You apply again, then you get pods, and it's back to 1 from 4. So that's what a deployment does, and it just has a container definition, just like a pod has, but the deployment manages replicas. Yeah.
Maria, just a quick one.
Yes.
Probably two things for our attendees. I think you use kubectl create and kubectl apply
Yes.
when creating the resources using the declarative approach. Probably you could shed some little light there.
Yeah. So kubectl apply is usually for updating changes to a file. So if I do kubectl create again, it will show that the resource already exists. See that? So this create is usually for the first time when you're creating the resource. So it will show the resource already exists. But if I want to make updates to patch the resource, that's when I use apply, and for it just does updates on top of the existing resource. So that's the difference. Create is for initial setup. Apply is to patch and update the resource.
Yeah.
Does
Thanks
that
so much
answer?
for that clarity. Yeah.
All right. So the next one that we shall look at would be a daemon set. So sometimes you have a pod that you need this pod to run on every node somehow. Because if you use a deployment, the scheduler will look for a node to place the pod. But what if you want this pod to run on every node? What do you do? This is where a daemon set comes in. So scenarios are like, in case you want to monitor your applications, you want to do logging, monitoring. So you want to install a logging agent on every node. What do? Instead of a deployment, you use a daemon set. Yeah. So they almost do the same thing, but the daemon set runs on every node. So it has to be kind, daemon set, log agent. So you could also, it's the same way kubectl create, kubectl apply, or the imperative way, kubectl create daemon set, then the name, or kubectl apply. So let's try the declarative way, kubectl create Okay, I think it's in the other objects folder, kubectl create -f daemon set.yaml. You'll see that a daemon set has been created in the namespace demo app. So you'll see that it has created this object in this namespace. But how do you see that it has been created? It's kubectl get pods -n demo app. And you'll see that it has created the log agent. But how do we know the nodes on which this is running? kubectl get pods -n demo app -all wide. This will show you the node on which these are running. So you'll see that one is running on the desktop worker, the other is running on desktop worker 2. So the daemon set will add the pod to every single node. So it's usually done for logging purposes, monitoring, and stuff. So you can add an agent for a logging service using a daemon set. Then the other object is a stateful set. A stateful set is usually for these services that they keep states, like databases. Unlike other apps can use a deployment, it's the major one. But a stateful set for databases, for example, MongoDB, MySQL, etc. How does a stateful set work? Each pod that is created in the stateful set has a volume attached to it. In the volume is where we store. Remember we talked about volumes for persistence? Is where we store. So everything that's created in a stateful set has a volume. And another thing is, for them, they have a specific naming convention. The first pod in a stateful set will be, for example, Mongo -0. The second will be Mongo -1, Mongo -2. And these are also deleted in sequence, like they won't just be randomly deleted, they're deleted in sequence. But these are used for databases, for things that store a state. That's when you use a stateful set. So we could create a stateful set. Same way, kubectl create -f stateful set. So we already have a stateful set. We could delete it. Then we create a stateful set. kubectl get stateful set. So there's a stateful set called Mongo. You can describe it. Since it's the only one, we don't need to provide a name, but this is it. And how do these pods created by a stateful set look like? kubectl get pods -n demo app. So it has Mongo 0. What if we want more than that? We could say replicas 5. Then we apply, because we are patching on top. So it has been patched. So we have Mongo 1. You'll see that it's creating Mongo 2. So it creates them in a sequence. One has to complete before the other goes. Unlike a deployment, so it's creating Mongo 3. So you can use the -w flag to watch the sequence. So it's creating Mongo 4. And I think those are the 5 replicas, yeah? If we make them 3. So kubectl apply -f stateful set. So it has created them. So you'll see that they're now free, 3 of them. So that's a stateful set. We could remove it now that we're done. So the other object, but most of these objects, they follow the same structure, all of them. It's the kind that changes, and the kind determines what you define here. Yeah.
Yeah.
Then we have, yes, please.
So this is on behalf of the attendees, yeah. So looking at the YAML file, right? One key bit on top is the API version, but then also you're talking about stateful set means that initially the initially created pods like stateless, more like ephemeral, something like that. Yeah, that.
The deployments creates stateless, like they're ephemeral. They can be you can spin them up again without having to worry about losing data. For example, now Mongo, sometimes it stores data in different volumes, so that's why it has to be a stateful set. Kafka, etc.
Yeah, that clarifies. The other bit is on API version.
Yeah, so the API version is always the same, and it depends on the Kube API version that you're running. You can find it, and then it's usually apps v1. This is the stable one now. But you can always define others for test purposes, but it's always the same for most objects that you define in here.
Okay. Yeah. Thanks for that clarity.
Yeah. Then stateful set. The next object we could talk about is a config map. So a config map is just a store for your key value pairs, for your variables. But the difference between a config map and a secret, in a secret, you store sensitive information in base 64. So a secret can never store plain text. You would rather store that in a config map. But let's see. kubectl create -f config map. Okay, it's been created in demo app because it's also a namespace resource. So this is our config map. You can describe it. And now, if you want your pod to access the values in the config map, you can reference this in a pod. That's why they store information here. But it's just a set of key value pairs with information that can be seen, not secret information. Unlike a secret, for a secret, yeah, for a secret, this is how it stores its data. This data is not visible, but there is a command you can use to find this information in the secret using JSON path. So you could look that up. But of course, it stores this in base64. You could also see this information easily. You could say, for example, echo this command, then you pipe it to base64 decode. Then you can see that it's called Mongo user, then also your password. So you can encode and decode it, then you store it in the secret Mongo path. Then you store it in a secret. The reason for this is just the secret just helps to maintain some sort of security that this data is not easily accessible. Then the next resource would be persistent volume. So we talked of volumes in Docker. Now we also have volumes in Kubernetes. So a volume, for example, if you have external storage, you have EBS, you have EFS, you have NFS, whatever file server you have, and you want to somehow get a portion of this file server, the portion of this storage into your kube cluster, you can claim it. And when you claim it, it's provided as a volume, and this volume is accessible to pods. For example, we saw a stateful set accessing volumes via volume mounts. Yeah. So whenever you need to access an external storage, or it could be internal, the empty dar or the host path, you could use a PVC and a PV. Creating a volume has two ways in Kubernetes. You could use what we call static provisioning, or you could use dynamic provisioning. So static provisioning is where you define the PVC and you define the volume. Dynamic provisioning, when you set up your storage in Kube, it will automatically assign you a volume if you give it a storage class that I want a volume that's in this storage class. You can read up on that, but the persistent volume claim is important because it shows that I want to claim a volume that has this storage, 1 GI. That's what you'll be given. You cannot claim a volume that has less storage than what you're claiming. Yeah, so it has to be that. And also you can provide the access mode, read, write once, read, write many. Yeah. So you can define a volume and a PVC, and that's what Mongo can use to store data. Then the other is RBAC. So sometimes we all have access to a cluster. Backend engineers, front-end engineers have access to the same cluster. But sometimes you want to put an extra layer of authorization. Who can do what in your cluster? And what do? You set up some form of RBAC, role-based access control. You control access based on the role someone possesses in that cluster. So what do? The first thing is to create a service account. Yeah. The first thing is to always create a service account. And this account is bound to a role. A role is like a playbook that defines what services you can access. So if the role is called demo role, for which it defines that whoever takes up demo role will access only pods with get, watch, and list. So you cannot delete a pod using this role. If you have this role assigned to you, you cannot. Role binding is what binds the service account to the role. So you will see that in its subjects, it has the service account and it has the role. So this is just a connection of these two. So let's create that. kubectl create -f rback. So you can get service account in the demo namespace because that's a namespace resource. So it's that. You can describe the service account. And it will show you information in case there's a event, anything that has taken place with this service account, it will show you. Then it has the role. The demo role has been created. Then we have the role binding. We have the role binding. So there's also a cluster role and cluster role binding. Cluster role and cluster role binding are not namespace resources. So that's the difference. For the cluster role, you'll not have a namespace or namespace for the cluster role binding. But they'll all have a service account, and cluster role gives cluster-wide permission. So that's the difference. Then another resource to look at before we go into the demo would be to go to, we've looked at the deployment, we've looked at the next one would be the service. So how does one pod talk to another pod? It's via the service. The interpod communication is via a service. So without a service, the pod cannot communicate to another. For example, we have kubectl get services. We have a Kubernetes service. So let me check if we have a service in here. Okay, we have some services here. And we have a KDC service. I could remove one. Let me remove one so we can recreate it. Wrong namespace. So how do you create a service? kubectl create -f. No, it's in the other folder. kubectl create -f service. The YAML, then kubectl get service -n demo app. So information about this service is the service is of type cluster IP. So whenever your service has cluster IP, it means it can only talk to another pod within the cluster. If it has an external IP, that means it can talk outside the cluster. So there are three types, or four now. There are three types of services. We have the cluster IP, we have the node port, we have the load balancer type, and we have the gateway API. I think this is a new addition. You could research about that. So if you don't define a type on a service, by default, it will be a cluster IP. Yeah. So this service did not have a type. That's why they call it cluster IP. It's the default that is provided, and it helps with communication between pods. Yeah, we'll see how that works with the application. You can define a load balancer service. So if type load balancer, let's try to delete this and create it again with type load balancer. You'll see that it's trying to provide an external IP, but I don't think it will do this because we are running in Kind, and I don't think there's a controller for creating that. But yeah, it will stay in pending for now, but that type shows that it will create an external IP, and with the external IP, you are able to access the application outside. Then if it's type node port, if it's type node port, you'll see that the type has changed to node port, and it has assigned a port number in the ranges of 30,000. So how do you access an app that has this service? You get one of the nodes, kubectl get nodes, and dash o wide. Oh, sorry, dash o wide. Then you get the IP of the node, and then on that IP, you assign the port number. So that's how you access an application that has a node port service. You get one of the IPs of the node and you assign a port number. So that's it about these objects in detail. Then we shall try to deploy an application to the cluster using the objects that we have talked about. Stephen, is there any questions so far?
So far in the chat, none, but I see someone's typing. Probably you talked of something to do with the controller when you're showing the load balancer. Probably you could just share a brief on what you meant by controller for the team. But yeah, there's also one. What are some of the recommended ways of managing Kubernetes secrets? Since secrets stored in basic step are usually easier to decrypt, like the way you did. Someone accesses your cluster, it means they can easily decrypt these secrets. Probably you could also share some hints there.
Okay, so remember the RBAC we talked about, the role-based access control?
Yes.
Okay, so this, you could use the roles and the role-based access control to define the resource that people should access. Yeah, to define the resource that people should access. So the thing is, for this cluster, I have nothing. I haven't set any. Yeah, I don't have a service account assigned. But if I had done that, you could define resources that people can access. So in those resources, secrets are not listed. So a person who has that role cannot access them. Yeah, but this was for test purposes. But in more serious environments, you could use that. Yeah.
Yeah, that sheds some clarity. Probably in the bit of the controller. Oh, we're ahead. You were coming there.
What's the question with the controller? I mentioned something with the controller.
Yeah, I remember when you provisioned with service type load balancer. So it was in the status for the service was pending.
Oh, okay. Yeah. With other setups like the managed services, you would usually not have any problem with this type load balancer, but it's because I'm running Kubernetes in Docker. I'm running Kubernetes in Docker, so I really don't expect this IP to be set up. I need extra For example, if you install in Kind, you're expected to have a controller. We're going to get there with Ingress. You're expected to have an Ingress controller, and the Ingress controller will help you to manage the paths, the routes to the Ingress. So without that, you don't expect it to work. So we are going to also look at that.
Okay. Yes, another question. A bill poll is asking, how does Kubernetes handle stateful services that need to persist data, e.g. Postgres?
So that's the stateful set that we talked about. It uses volumes, persistent volumes. So when you create a volume, you can mount the volume here via volume mounts, and you provide the name of the volume claim, which is, for example, Mongo PVC. So when you provide that claim, Mongo PVC, it will look for any storage that's 1 GI, which is this one, and it will assign it to you. So the mount path, you're saying, I want to access that volume via this path. So when you go into your pod and access this path, you'll be able to see the information in that volume.
Yeah, which is very similar to what you do in Docker. You specify the data directory when you're attaching a volume to container.
Yeah.
Oh, okay. That is insightful. One more question on secrets. Kelvin is asking, what about secret rotation? Is there a way that these can be rotated automatically using Kubernetes, like how they find it in HashiCorp Vault or AWS Secret Manager?
Yeah, it's secret rotation is also possible. You can always use other services, as we've mentioned, and it's very possible. Secret Manager, etc. It's very possible. You cannot, you can if you look for it and extend it. It's possible.
Yeah. Oh, okay. I think questions have been answered. Thank you. Thank you so much, Maria.
Right.
I think we can commence further.
Yeah, okay. So we're going to try to deploy a simple, very simple app. I'll try to run it with Docker, then we'll see how it works with Kube. But this is just a small static application, just an HTML page with a Docker file. And yeah, that's it. So we're going to try and deploy this. So that's the first thing we do. I think remember that with Docker, let's check if that image does not exist already. Okay. To build it from scratch, let's first remove this image. It's not. Okay. Docker remove. I think it's called what? KDC app. Yeah. So I need to move into this context. Build HD KDC demo. So our image has been created. Now we need to, for test purposes and to just recap about Docker, let's just try and run it. If we could run it on port 3000. is it running on? Port 3080 because of Nginx. Then the name of the container, then the image. I think we call the image KDC demo. Is it? Wait. KDC-demo. Oh, this is the name of the image, then this is the container. Docker entry point not found.
So this tag does KDC-demo.
Yeah.
We need the specification of the tag.
Yeah. So now this has been created, and I think we could access it on our browser. Yeah, so this is a simple app. Now we need to deploy this with Kubernetes. Yeah. So I'll stop this container. Okay. I'll stop and remove this container so it's back. Now let's deploy this. So how do we deploy this? For every Kubernetes deployment, you need the basics. The basics is the deployment.yaml. If it's not a stateful set, if it's not a database, then you will need a service. For every deployment, there has to be a service for communication. Yeah. Then the ingress will come in later, but the basics is the deployment and the service. So in our deployment, we created an image called KDC-demo. Yeah, KDC-demo. So that's the image name. So let's try to create this demo app. But we have to confirm that it doesn't exist already. Okay, there is no deployment called, okay, there's a deployment called KDC. Okay, let's change this to, so you go into the kube folder, kubectl create -f deployment.yaml, so we can get the pods that have been created. And we see that KDC demo has been created 6 seconds back. And it's running kubectl describe pod -n KDC demo. Sorry, okay, demo app, that's our namespace. So it has pulled the image, KDC demo latest, and it has created a container for us. Now, how do you know the logs? Sorry. Pods -n KDC demo. How do you know the logs? kubectl logs. You're able to see the logs of your container. Yeah, they are logged here to std out. So that's what you have there. And now, how do you communicate? How do you see this in the browser? Because if we come back to localhost 3000, it is definitely off. So how do you get from this point? You need a service. The service should be in the same namespace. So we need to create a service. We come to service.yaml. Let's give it a name. Our app is called KDC Demo. Port 80, target port 80, because we want to access it on localhost 80. So let's define the service, kubectl create if service.yaml kubectl get service n demo. App, the service has been created. It's a cluster IP service, but still, if you go to localhost 80, it's not working because cluster IP is for internal communication. But why is it working then? Because of kind. Okay, but then what if we want to give it a sensible name, not something? This is where the ingress comes in. The ingress helps with the HTTP requests from the browser, that you can define that I want to access this service on this domain, and for it, it will map out where to go. So the first thing you need to do is to add an ingress controller. This is how it looks like. There are many ingress controllers out there, but the commonest is ingress Nginx. Yeah, it's the Nginx controller. And this controller will create these services. It will create the namespace. That's ingress Nginx. So if you go to this namespace, you will see everything. That's in there. You will see that it created pods. It created a service for the ingress controller, and it created a deployment. So the fact that we have an ingress controller, it created an external IP, it created a replica set is more like what powers the deployment. So in the background, the deployment runs a replica set because it helps with the replication that we saw. Then other objects, it also has a job. A job is something that runs and completes. In case you want to run something in your app, you can create a job. It's also an object that you can look at. But to create ingress, you need a controller, and this is it. You can run kubectl apply and get that ingress controller. So another thing it creates a service account. This is what we said when you want to authorize what this controller can do and what it cannot do in your app. It has a service account for the ingress. It has a service account for the admission controller, and then it has roles. Here in the roles is what is where you define what it can do. It can access namespaces, and in the namespaces, it can only get namespaces. It can access config maps, pods, secrets. It can only get them. It can access services, get list watch. So you can see the different resources that it can access and what it can do. Then the role for the admission controller, also what it can do. The admission controller can create secrets and you can get them. Then we also have the cluster role, and the cluster role binding. We said this is not a namespace resource. but you can provide a cluster role to access resources across the cluster. Then the role binding, it binds the service account with the role, as you can see. Then the role, same. So role binding, cluster role binding for the admission controller and for the Nginx itself. And then the service types, you see there's type load balancer, there's type cluster IP for the webhook. So, and there's a job. What does this job do? This job runs a specific container that does what? Generates a SAT, kube webhook SAT gen. Same. So it also has the ingress class. So in your ingress rules, when you make an ingress resource for your own, you reference the ingress class here. So that's the name, that's the resource that you're referencing. The ingress class that you call here is here. Yeah. So if this is wrong, you're going to have problems with the ingress. Then it has webhooks that validate resources. Still, that's the ingress controller. It's available. You can use Nginx, and you can also look into other alternatives. So how do you know that you have an ingress? kubectl get ingress. Let's see, we have demo app ingress. Oh, we already have an ingress. That's why I was able to access it on port 80. Okay, kubectl delete ingress. Okay, so okay, now we have that. We're back. So this is our ingress. You give it the name, the namespace, the ingress class name, and the service. The service is important. The cluster IP service that you created is really important to define the ingress service. So KDC demo service on port 80. kubectl create -f ingress.yaml. So the app ingress has been created. Yeah, it has been created. But before that, I think we need to see the ingress controller, what it's created. So we go to kubectl get all -n ingress Nginx. So everything the ingress controller has created is in here. I think we already saw that. Sorry about that. So we see now we can access it on port 80 because of the ingress. So the ingress helps you to access resources rather than using a cluster IP, but externally via your browser with HTTP or HTTPS. So do we have any questions so far?
I would say so far so good. But yeah, I think questions will come in on a rolling basis. There's one. When can someone choose between cluster IP, node port, and the load balancer service types?
Okay, when can someone choose? So if you want your application to be accessed externally on a domain, yeah, on a domain, for example, example.com/, or you want to have another being accessed at another path. For example, API, yeah, /API. This is another service, yeah. That's when you use the ingress. Ingress is all about external access. Load balancer is all about external access, but load balancer provides an IP address, not a domain path. Node port and cluster IP. Cluster IP is for internal communications. For example, you have MongoDB, or you're running a service that you wouldn't want to be accessed externally via the browser. That's when you use cluster IP. And node port is also external access somehow. So cluster IP for internal communications, node port, external communications. As long as you have the node port IP, you can access your service via the node port. Load balancer, external access, and ingress external.
Yeah. I think it clarifies.
Yeah.
Kindly take over.
Yeah, okay. I think we have 14 minutes to go. I think I would be open for questions.
Yeah. Probably I would request anyone with questions to type in the chat, but yeah, I think I've been noting some few here. So I think the first one is on if you go back to the repository. So this is good if you have one application, for example, right?
Yes.
As you can see, an app. So what happens when now the number of apps grows? Say you're working with, say, because we looked at container orchestration running multiple services, right? I have microservices, I have like 10.
Yeah.
Will I create like 10 deployment files, 10 service files? So
Yeah,
how
each app should have a deployment. So yeah, if you have another, for example, front end, then you have back end. In your definitions, you should have deployment. I could add another deployment here. It can exist in the same file, but you just have to keep on defining them here.
So you're using that line separator, yeah?
Yeah,
Those 3 dots.
So you can call this backend. You can call this front end. Then you define the right image, yeah?
Yeah.
Don't forget, this could be the front end image. This could be the backend image. Then you have to make sure you have a service for each. You can add another resource here, front end service. Yeah. Then you define, the selector determines which service you're pointing to. So if our deployment is called KDC frontend, so the service will be the selector app you connect it to KDC frontend, like that.
Yeah.
Then you can have as many services as possible within the same file, or you can create different files. And then you can have, after having a service, you can create the ingress. So, for example, if this is the front end, you can access the API, yeah, via the same ingress rule, but as long as you point to the right service. So the right service here, for example, this is the front end. So you could call this /front end. So in the URL, you could do localhost /front end, like that. Localhost /API, or whatever domain you have /. So what determines that is the ingress. So you can add another path, and you call this path /API, and here you define like backend service, something like that.
Yeah.
So you can have multiple resources, but you can have you need to have different deployments for them. you need to have different services. For separation of concerns, you need to have ingress paths defined. But others can run the same containers within a deployment. I mean, another container. But this is not really advisable. But yeah, you can try out stuff.
Yeah. So quick one. On the bit of running running pods, yeah.
Mm.
In regards to best practices, what do you advise? To run multiple containers in one pod or to run one container in one pod?
I would advise, first of all, it's always good to separate concerns. You could run a single pod with a single container, but it depends on the resources of the pod. For example, if the pod has resource limits that it's not supposed to exceed this amount of resources, it's always advisable to run a container that has enough space. Yeah, you can't include so much containers in a pod that has very little resources. So it's always good to separate concerns. And another thing, you look at your resources. If you can do that, it's fine.
Yeah.
But at the end of the day, it's just resources and what your team prefers.
Yeah. So I think for attendees out there, you saw some people asking for the repo. Now, what if someone wants to create the same manifest files or probably read more? How can they get started?
Yeah, so if you want to create the same read more, there's a repo here. I think I'll provide the link. Okay, yeah, it's this one.
We already shared that in the link, yeah, from last time, right?
Yeah, this has everything that we've talked about today, the resources and whatever. So I could add that to the chat. Yeah, but another way, Kubernetes is a very big ecosystem. Another way, this is the simplest, where you create the YAML files, the manifests. But you could also look into other better tools in production. Yeah. For example, Helm. Deploying your resources with Helm is good because Helm keeps up to date. It keeps resources up to date, and you do not have to manage multiple resources. For which it handles that for you. You just need to define a values file, and it has the templates already created for you. For example, let me see if I have Kubernetes Ingress Helm. So we have chats. So you see a Helm chart. Usually you just need to provide a values file for your own. The values file will override this one that they have, but they have a chart, and in this chart, it has templates, and you see the YAMLs are already here. Yeah, it has the YAMLs, and you can use this to define what you want. For example, you want a deployment. It's already defined for you here. How? In your values file that you've provided, you say that if the kind is deployment. So in your values file, you define, in your values file, you define the kind, deployment. It's back to charts, Ingress Nginx, values file. So in this values file, I'll find kind, deployment. So I could provide a values file and say, no, I want to use kind daemon set. So what does it do? It will go to its chart and it will look for controller daemon set, because you've specified kind. If equals kind daemon set, then it will deploy that. Yeah. So people tend to use this in production because you don't have to manage so many things. For example, the question you asked about having so many applications, creating deployment files for them. Yeah. You could use Helm. Helm can manage that for you. You just need to define a values.yaml, and in that values.yaml, you define what you need. Yeah.
Yeah.
Then it will create that for you. Another tool is Customize. Also, this is also used in production, and it also does almost what Helm does for you. You need a values file, then it will do that. So to further practice with Cube, you could start with the easiest way, that is to use small manifests. But in case you want to run this in production for larger applications, yes, this still works, but there are easier ways to handle this. And you could look into Helm, you could look into Customize, and other ways that we defined earlier in the slides. Yeah.
That is insightful. You've commented on a key thing, Helm, which is a key thing. What I think one other one was on Kubernetes. Like in the previous session, we talked of DevOps. DevOps should get used to living in the terminal, but managing this over CLI at a large scale can get overwhelming, right? So I think some ClickOps is key, right?
Yeah,
Probably
it's also
what advice would you have for that?
it's also important that when you're starting out, yeah, when someone is starting out, it's always important to learn the heart of these things, the basics, what runs in the background. Yes, ClickOps is good, it makes life easy, but sometimes you need to know how things get connected, how things work. To get deep knowledge in Cube, I would advise also to do Kubernetes the hard way. Yeah. There are those resources on GitHub, Kubernetes the hard way. So this project, yeah, will help you understand how these things work together. But of course, this is just for test purposes, for learning purposes. Just like I said about the terminal, for learning purposes, you'll get to know how etcd connects to the API server, how the resources work together and communicate. So to improve your knowledge, look into Kelsey Hightower's Kubernetes the hard way. This will help you further reinforce these. And yeah, also living in a terminal is good for getting started, learning. But for those that already know how to do things, you can always run to the UI. ClickOps is
dashboard.
Yeah.
Sometimes things get overwhelming.
Yeah.
Resources are more.
Yeah, I know, but sometimes you need to know how things work in the background.
Yeah. I saw you had the best practices sheet. Slide.
Yes. Best practices. So, readiness probes and liveness probes. We haven't talked about them so much in this discussion, but look into how to set up readiness probes. A readiness probe will help you know that your app is ready before it receives traffic. Yeah. So, for example, you have a backend and front end, and the front end needs to communicate to the API, and the API is not ready, your application will fail, and that's what your customers will see. So to avoid that, for example, for new deployments, before your backend starts serving traffic, you have to have a readiness probe that confirms that, yes, the container in this pod is ready to receive traffic. Let's connect to it. Yeah, that's what a readiness probe usually does. Liveness probe, it just checks if the app is live itself, if it's online, if it's running. It does not check the depths of whether it's ready to receive traffic. Then config maps and secrets, it's advisable to use those. For example, if you had to keep things clean within your cluster, not to have variables manually defined, hard-coded here and there, it's important to use config maps and secrets. Then enabling logging, it's good to have a central location for logging. There are tools that can consume data from your cluster. You can use Datadog. We have Prometheus, Grafana. You can use these tools to get logs and to get better diagnostics of your pods. I could just say kubectl log pod A. I see that information, but it's not as critical, or it doesn't give better diagnostics compared to what a fully fledged tool would do. So you could enable logging, but of course not so much logging because it can get expensive. But you can know what level of logging you can enable if you're just error info or warnings, anything that you can enable. And then you can also implement resource requests. We talked about a pod reaching limits or CPU. Sometimes these pods, if you don't set resource requests, they can get heavy and consume resources for all the other pods in a node. So you end up finding a node unschedulable because one pod has taken up all that space. But if you enable resource limits and CPU and memory, a pod will know that if I exceed this resource limits, I'll die. That's what happens. So you keep some sanity in your cluster. Then also pod security. We were talking about vulnerabilities previously. Pod security, you can define the security context in your pod. The security context shows that this pod can run as the root. This pod cannot run as the root. So you can determine which user can run this pod. That is done via the pod. You can say, I want to define the security context. You can look at that in the documentation. And then you define run as user, run as group, etc. So you can define the security context in a pod. And then image scanning, it's important to scan your images for security vulnerabilities. So all the time something comes up in these images. Either they're outdated and there is a loophole that someone can use to manipulate your app. So it's always good to scan for any issues. Docker introduced, there's something I saw, I think it's Docker Scout. And this scans images. Yeah, sorry, I saw it. This one. Docker Scout, scout.docker.com. This scouts images for vulnerabilities. But in case you're not using that, how else would you scan? There are other tools. We have Trivy. Trivy, you can include Trivy in your pipelines, and then it will scan your images. Of course, there are also others like Dependabot. Dependabot, you could also have a look at that. And then we have Renovate. This one will help you with updating dependencies. So you could also include this in your pipelines. Yeah, so that's it about this slide. Image scanning, pod security, managing secrets, and logging.
Yeah. Wow. Truly insightful. Yeah.
Yeah.
I think at this point in time, we started 15 minutes late, but I think, squeezing all this content with a technical demo in such a short span, the next true spot. And I would like to take this. I would like to thank you on behalf of Kampala DevOps community, Maria, that Thank you so much for, cooking, preparing such an insightful presentation. We started all the way from Docker. You're on holiday in Uganda. You took us through a detailed physical session. We decided to have part two of this. You've taken us from understanding what containers are to, looking at container orchestration, and all this is encompassing best practices. I think I think people are seeing you preparing, I think deleting some services set prior, and
Yeah.
you could see that this takes effort, right? Such that the demo is on point, and I think the team on the call can testify. Yeah, so on behalf of Kampala DevOps community, we are really appreciative, and we are saying thank you so much. It really takes effort, and Martha giving back to the community. It's really, 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 really insightful. Thank you so much for taking us all the way from, I think, for almost this span. You've been really taking us through, the container section, giving us a deep dive on the best practices, and us getting to dive, into your experience, which is truly, truly important. And I think you can see that from the hand claps of the team. We are,
You're
and I,
welcome.
I think one can testify. I think the reviews from the first session,
Yeah.
people really gave good testimonies, that the sessions were truly, truly insightful. Yeah, big time thank you.